Okay, I'm Sarokram. We'll be doing our practical, and this is the practical that I have, practical number 5, to complement a block of data at a block of memory. So the question is, we will make it more clear. We will complement a block of data and store that complemented data in a block of memory. So we will collect some data from a block of memory, complement it, and store one after another to a block of memory. So for that need we needed to select from where we have to do it. So all those, the source data, it will be pointed by that the address will be stored in ISNL, and the destination data destination will be stored in DNE. So the address are stored, the initial addresses are stored in ISL and DE peer. So we use a this in instruction so that it is versatile. It can change whenever you want to use this program for any block of data, not fixed address. So we after we select the data address, we enter in ISNL, D and E, and we use one counter, that is C, and the counter is nothing but the size of your number, means the number of data that you are going to complement. If it is 15, then select 15, then put the counter 10. So it is possible through this in instruction. So in instruction you have already studied. In is what? Whatever you give, it will be stored in accumulator. So we need to transfer from accumulator to the particular destination. It can be C, E, D, any problem, no problem. But we cannot directly give a number in this other way. Only this instruction is there to change the data whenever you run the program. So next is we move the first number from the memory pointed by ISLPR, because we are using this instruction, move A, M. So from this memory location to A, the data will be copied. The memory location is pointed by ISNL content. Then we complement accumulator. Then whatever is complemented, we transfer to the destination memory location pointed by D and E register pair. Then we are going to do again and again. So this is a branching operation. So in the branching operation, what we increment the memory location of the source, and we increment the address of the destination. Then we decrement the counter and check for 0. If it is not 0, then because of this instruction Z and Z, we jump to this instruction. So it is repeated till all the data are collected, complement, and stored at our destination. So we will be using so I will use, your sir may be using, or you may be using another software, but I am not that much expert in other software. This software I will use it, that is IT5 Simulator ITE. So over here you have the option of tools. You have memory editor, you can edit the memory. So we can make a block of data. Then this one is your assembler. This assembler, I have already written the program. So these are all the program that I have put in PDF also. so you write it. So this is versatile. So now I let me do an assemble, and I will start the simulation. So this program is now loaded in this simulator, so I will start it. So this is step by step the rate of doing the program. See, step by step, slow. These are all some you have to learn. So then step by step means one instruction at a time. So you can see whenever this in instruction is there, it will ask for a data. So what we have, let's select our destination as IT, sorry, source as IT. So let's edit it, enter. Okay, we have not enter, so 0080 IT, I have not click it, IT, enter. So we have entered it. Now this IT will be put in L. In the next step, see, IT has come over here. It is transferred to A, from A, IT, move A comma L comma A. Now let's edit 5. So as we have selected, this one is our first source, this source address 22, 23. Let's enter 24, 25, 25, 26. Okay, how many? 1, 2, 3, 4, 5. 5 data we have entered. Let's see. Now, and our destination, let's use it here, starting from here. So that means the address is 0090. So 00. So our address now, our source this address start from 0080. Next, this will be our destination 90, enter. So 90, E part is 90, 00, now 0090. Now let's come to the our counter. The data size, number of data is 5, so we will give 5 to C, and it will be transferred to C. So we have finished selecting the number of data, source address, destination address. Now we are going to move the first data from memory to accumulator. So that is 22. So you see 22 has been moved. Now next step is complement A, and it become DD. It is in hexadecimal number, so when you convert it, you will find that it is DD. Okay. So that DD where we are going to transfer to 0090, this address. So you can see that DD has come over here. So next we will increment the next location, source location, from where we are going to take. So it will be 00000081. Zero. At 1. Okay, so then D also will increment, it will be 0091. Then we will decrease the counter, so it is 4, and then after that we will check it whether it is 0 with this instruction Z and Z, and if it is not 0, then we will jump to this instruction given by the next. So that is move A comma M. So the second number is move. So second number is moved, that is 23 from here, and it will be complement, and it will be sent to 91. See, DC. Okay. So like that we will finish all. So it can be, so can stop, and you can see normal. You can select the red normal, and you can do the start. So we have to again IT, enter 00, enter 90, enter 00, enter 5, enter. See, it's so fast. Finish. Okay, let's try to add another one. So let's select 40 and 50. 12, 13, 14, 15, 16, and 16. How much? 17 and 18. Okay, oh sorry, I have not entered 18. So how many? Yes. Ah, yes. Hmm. No, 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 nothing. Only my LIC part and this EPF plus. It comes to 150, 1 lakh 50. Uh-huh. Over 18, 19. How many? How many? 1, 2, 3, 4, 5, 6, 7, 8. Oh, data size is 8. Let's see. So and start from 40 to 50. So uh, now start. So you can see that whenever I start, it will accept the new address. So 004. Sorry. Wrong entry. Only two. So 40. Okay. So 40 is transferred to where? 10. Then 00 will transfer to 40. Then what? 50. Let's store in 50. 00. Okay. Then counter size, how much? Data size is 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8. Enter. See, it is transferring. It is complementing, and now it is finished. So you can select any group, any data, a group of data from any location, and complement it, and you can store it. So this is a program which is very flexible. Okay.